A Geologic History of Iceland by me. Before we get to its actual creation, we have to talk about what took place before Iceland creation because it was important to how it was formed. Around 100 million years ago, the Atlantic mid-ocean ridge system was formed. Shortly after, the Iceland volcanic mantle plume was also formed. Around 55 to 70 million years ago, Greenland started to slowly drift over the Iceland hotspot, but there was no volcanic activity yet due to how heavy and thick the Greenland crust was. Eventually, Greenland drifted away from the Iceland hotspot and volcanic activity started taking place. For a million years, basalt lava would spill out from the mantle plume, and some of it can be found today in part of Greenland, Scotland, and Ireland. Now let's get to the actual creation of Iceland. Around 20 to 25 million years ago, with the ongoing activity of the mantle plume, mantle material was coming out from the plume and rose to the surface. And when it reached the surface, it started cooling down. As the material cools down, it started accumulating and began to form Iceland. Also, Iceland was lying on top of the mid-Atlantic ridge, so it was affected by the shifting of tectonic plates, more specifically, divergent plate boundaries. The combination of tectonic movements and the mantle plume activity helped shape Iceland as we know today. Around 3 million years ago, the Ice Age started. There were around 30 cold periods and 30 warm periods, and during these periods, it would change the geology of Iceland. Glacier and ice will cover Iceland during the cold period. While Iceland was covered in ice, fords and valleys would be created due to the erosion of glaciers. And around 10,000 years ago, the Ice Age was over. Now let's talk about the present of Iceland. Iceland is currently located at the junction of North Atlantic and Arctic Ocean. Iceland's location is on top of the Mid-Atlantic Ridge, where the North American and Eurasian tectonic plates meet. Iceland's coastline is approximately 4,970 kilometers, or about 3,088 miles. Iceland is primarily made up of basaltic mineral composition. Basalt makes up about 9% of Iceland. In this picture, you can see the Mid-Atlantic Ridge going through the middle of Iceland, as represented by the blue line. The red dot represents the hotspot currently underneath Iceland, or you can call it the mantle plume. Since Iceland is on top of a ridge system, volcano and earthquake can be triggered. Due to the divergent plate boundaries, earthquakes are frequent. There are also about 30 active volcanoes in Iceland, and those will go off in the future, but we just don't know when yet. Now let's talk about its future. Every year, Iceland is spreading by 2 to 3 centimeters or 0.8 inches. Eastern Iceland is drifting to the east, while Western Iceland is drifting to the west. And because Iceland is on top of a spreading center, new land are being created because magma are rising from the North Atlantic Ridge. Volcanic activity will continue because of the ridge system and the hotspot underneath Iceland. There's all around 30 active volcanoes right now, but there could be more in the future. And that is all for the geologic history of Iceland. Thank you.